Hello everyone, my name is Satyakam Pratap Singh. So this is the 7th tutorial session for the network analysis course whose instructor is Professor Tapas Kumar Bhattacharya sir from IIT Kharagpur, and I am Satya, and I am PMRF research scholar at Department of Energy Science Engineering, IIT Bombay. So this tutorial session will help you to solve the assignments of the 7th and the 8th actually. So some of the questions I have kept for graph theory, and some of them are related to the network theorems. Okay, so if you face any doubt related to audio quality or anything, just let me know in the chat box. Okay, so I'm out of station, so I'm not actually able to open my camera. Okay, so this is the first question before you try to solve this. This is related to network theorems only, so which we have studied in the last class. So some of the portions I have kept for the network theorem, some of them being for the graph theory. 1 hour for the graph theory and 1 hour for the network theorems. Okay. Try to solve the first problem. Try to solve this first problem. Whatever option you got for the answer, just write in the chat box, or you can open your mic and also ask. This simple problem related to the Thevenin impedance only. If you have taken the last tutorial session, that will be helpful for the solving of the few of the problems. Okay. Anybody who wanted to give the answer? Okay, let me give the solution for this. After that, I will give the other problems also to solve the other persons as well. So in this question, what is saying that in the figure, this Z1, it is given as, if you say it is given as 10 angle minus 60 degree, and Z2 is given as 10 angle plus 60 degree, and Z3 is given as 50 angle 53.13 degree. Okay. So in the question it is asking Thevenin impedance basically. So if you see that this Thevenin impedance, there are some procedure for solving this kind of problems which I have told in the last tutorial session. So for Thevenin impedance, you have to replace the voltage source by their internal impedance basically, by internal impedance. So in this problem, it is not mentioned whether what kind of impedance is with voltage source. So you just have to replace it by the short circuit. Basically, there is nothing is there. So this is a kind of Z1, and then Z2. It will come like this, and then Z3. Okay, and this is the X, and this is the Y. Okay. So it is being said that, okay, what is the Z Thevenin impedance basically? So Z Thevenin will be Z1 parallel to Z2 plus times of Z3. Okay, so this is simple manner. Okay, whatever the Z1 was there, Z2 was there, just use the this because the Z1 and Z2 are in parallel, then this whole combination is in series with the Z3. Okay, so if you face any doubt related to voice or means writing, if you're not getting anything, just let me know. Okay. Okay, so this is a Z1 in parallel with the Z2 and then plus Z3. Okay, this is simple problem. So in the answer it will come out to be option A. Okay, so let's move to the second problem. Try to solve this.
The in previous question, how to convert a rectangular form to polar form.
Okay, it's a not a very difficult. So let me take another slide for that. So in the calc itself, if you are using calculator or anything, then you can easily solve that. Okay, but if it is a
Sir,
given at
in exam, calculator is allowed as well.
yeah, yeah, in exams, in the GATE exams also. I don't know about this means NPTEL exam. So you can see the guidelines basically. So in the guidelines, actually, it will be mentioned. Okay. So if you see the guidelines, it will be mentioned whether it is calculator is allowed or not. Actually I'm not aware of that. So let's try to solve by other methods and without calculator as well. So if in this question, suppose this Z1 is in parallel with the Z2 and it in series with the Z3. Okay. Suppose the question is asked in the polar form or Cartesian form, just use the what is given. So in this question it
I
is,
got
yeah,
40 plus j point 8, sir. Then how to convert into polar form?
you can use this formula. No? Suppose a plus jb you got. So in the calculator if you see, so this is actually a square plus b square and tan inverse b by a. Okay, this will be the angle. Okay, so this is, you can
Okay.
directly convert from this one form to the another form, and you can see that key in which quadrant it is actually appearing. Suppose in the first quadrant, suppose this is a and this is the imaginary plane b. So if you see, this is a whole term sign positive positive, or it's a negative positive kind of, and this is the means positive negative and negative negative. So based upon that only you have to suppose in this, just theta will be angle between the 0 degree to 90 degree. Here theta will be angle 90 degree to 180 degree, and here the theta will be angle 180 degree to 270 degree, and in this theta will be angle 270 degree to 360 degree. Okay, or in the negative also you can take. Okay, So based upon what the A and B values are there in that form, you have to convert basically 180 plus or something, 270 plus, like that. Okay. So this is the formula means method to convert from the one form to another form. Okay. Let's move to the second problem. Okay. Try to solve this problem. I request everyone to solve it because if you face any doubt, just let me know so that I can clarify that. You can open your mic and ask me whether at which point you have any doubt.
Option 3, sir.
Okay, I got one answer as option 3. Okay, others try to solve this. You can write in the chat box or just open your mic and ask. Okay, tell the answer. Anybody else? Take your time to solve. Huh? There is no hurry. And also, if you got the answer, just re-verify whether it is correct or not. Okay. If you are facing any doubt, just let me know so that I can clarify that. And if you don't know the methodology to find out the Thevenin or Thevenin resistance or Thevenin impedance or Thevenin voltages, just also you can let me know. Okay, I got two answers as one is the option 1, option 2, option 4. They are different variety. I got all the answers. Option 1, option 2, option 3 and option 4. Okay, let me solve this and clarify your answers. Okay, so see here, in this problem, it is asking whether the to find out the Thevenin equivalent voltages and impedance. Okay, so let's move to find out the first the Thevenin impedance. Okay, Thevenin impedance. Let's solve it first. So what was the rule? You just have to open the terminal where you wanted to find it out whether the equivalent, and then you have to replace the voltage source and current source with their equivalent impedances. Okay, here in the question it is not mentioned whether the internal impedances are there with the voltage source or not, so you just have to replace the voltage source by short circuit or and the current source by open circuit. Okay, so in this then there is no current source, so if there is only voltage source, you just have to short circuit it. Suppose I have sorted this terminal, this is terminal, this terminal. So one resistance was here, it was 20 ohm, and in series it was 10 ohm, and here it was there 10 ohm. Okay, so here the terminal was P and here was the terminal Q. Forget everything what was there here the unknown network. You don't have to know what is the circuit behind this. You have to just find it out the what is the Thevenin across the PQ if you are seeing from the PQ side. Okay, so you have already short circuited this impedance, so it will not come into the picture. Let me take the another pen for that. So this will not come in the picture because all the terminals here is the short circuited. Okay, so how it will turn out to be, it will turn out to be like this. It will be 10 ohm, this value, and this value will come in the parallel basically. So this is the 10 ohm. So this was the terminal P and this was the terminal Q. What will be the equivalent? It is in a parallel 10 10. So 10 multiplied by 10 divided by 10 plus 10, it will be equal to 100 divided by 10 plus 10 basically. So it is 20, it will come out to be 5 ohms. Okay, so this is the Thevenin impedance basically. Okay, so let me duplicate it. Any doubt in this? Any doubt in the Thevenin impedance?
No, sir.
Okay. If you have any doubt, just open your mic or you can write in the chat box. So writing in the chat box, it's a bit hectic. So you can just open your mic and ask me if you feel anything related, any doubt, anything related to this. Okay. So let me solve for the Thevenin resistance basically. Thevenin voltage. So for the Thevenin voltage, let me take another pen. For Thevenin voltage, okay, you just have to open circuit the terminal where you wanted to find out. Suppose you wanted to add the PQ, so I will rewrite the circuit like this. This this is the 4 volt here, and this is the 10 ohms, and here the 10 ohms basically. So this is 10 ohm, and this is the P, and this is the Q. Okay, and I have to find out the voltage VTH across this only, seeing from this side. Okay, whatever was there in the unknown network, you don't need anything about that. You just have to see from where you wanted to find out the VTH. Okay, just open circuit that terminal and connect don't you just open circuit it and try to find out what is the voltage across that. Okay, so in this circuit, if you see this 4 volt, let me take another pin for that. If you see this 4 volt, it is coming because it is this terminal is open circuited, so there will be no current across this. So all the current which will flow from the 4 volt, from the 4 volt, okay, it will go into this circuit, this 20 ohm, and another will go across this 10 ohm and the 10 ohm. So this is a 10 ohm here, and this is the 10 ohm where this is the P and this is the Q. Okay, so if you see this 4 volt, it is appearing across the both the resistances basically. So and the resistances are equal. So it is something like this. So this is the voltage and this is the resistance and this is the resistance. Okay, and the 4 volt will appear across this 10 ohm also, this 20 ohm combination, and this is the actually 20 ohm. So in this thing, if you see, so this 4 volt, what is the voltage division principle? If you have voltage division principle, finding out the voltage across this or this, okay, because the resistance are equal, so voltage will be divided equally. Okay, so this 4 volt will be divided equally between the two, so it will be V plus V, that is 2V, so V will be appear as a 2 volt. Okay, so the voltage which will appear across the P and Q, it will be 2 volt. Okay, so the correct answer will come out to be for option 1. Okay, any doubt?
No.
Okay, so this is the basic methodology to find out the Thevenin voltage and the Thevenin impedance. Okay, let's move to the another problem. Try to find out this. This is the easier problem, but I request you to solve it. Okay, in this problem, the current source that is already given, that is 1 angle 0 degree. Resistance is already given as a 1 ohm, and this XL, this ZL, basically it is given as 2J ohms, and this ZC is given as minus J ohm. Okay, you have to find out what is the Thevenin equivalent when you see from the XY terminal.
So Thevenin's theorem is applicable for linear circuit only, Mason.
Yeah, this is a linear circuit. A resistance means capacitor, inductor, they are the linear elements, and the current source also is a linear.
What is linear element?
So, linear and non-linear, there is a definition. Basically, if you see linear and the non-linear, suppose I take there, I have one problem also. So, if you see, suppose the current is actually some RMS value we have found out 2 angle 0 degree. Okay, so this is a kind of linear current source. If you get the values like this, suppose it is dependent upon something voltages. Suppose I got the V square plus 2V, it is dependent upon something else, something else. Okay, so this current is dependent upon some other voltages. So these are the dependent sources, and it may be linear or may not be linear. Suppose I is equal to V, so this is a kind of linear if the voltage is linear. Okay, so suppose I is equal to V square and V is a linear, so V square become non-linear. Okay, so dependency you have to see whether in the particular problems, whether it is dependent upon something, and when you're putting the values you get the non-linear terms or not. Non-linear means basically it is not varying with the exact value. Suppose this is the one, here the one also, or maybe 2, here the 2, so y is equal to mx kind of graph if you find it out. Okay,
Any non-linear elements examples?
non-linear op amp is a non-linear circuit. So this is a kind of op amp circuit is there. Suppose this is the one I'm taking here. So when you find it out the voltages across this, suppose this is the V, suppose I'm taking VAB something. So this is the V output, and this is the V1 or this is V2. So V output will be something AV times of V2 minus V1. Okay, so this is the amplifier gain AV. So this is non-linear circuit because it is dependent upon the something values, and also it is not varying directly, because AV value when you find it out there is different topology, there will be different impedances. One can be 1 plus Z2 by Z1. Okay, so this kind of topology, they are the dependent upon some other values as well. Okay, so these are the non-linear circuit. Okay, getting my point? And also
Yes.
when you see there, suppose the resistor is there. Okay, when you multiply it by 2, so it gain will be multiplied by 2 only. Suppose this is a 1 ohm and this 2R will become 2 ohm. So whatever the factor you are multiplying, it will be same factor. Suppose R1 I have taken as 1 ohm and R2 I have taken as 2 ohm. Okay. So when you adding the 3 ohms, R1 plus R2, its value will be 3 ohm. I suppose I have taken the 2R1. 2R1 is a 2 ohm and 2R2 is equal to 4 ohm. When you add the 2R1 plus 2R2, that will be same factor. Suppose I am getting 6. So that is same factor because this is the 3 multiplied by 2. So whatever you are multiplying in the different values in the linear element, when you add then multiply, then values will be also same. So there is a common factor that when you are multiplying the same values with the same elements, after getting, if you take the same linear values in the addition or subtraction, when you multiply the separately the same common factor, you will get the same answer. Okay.
Yes, sir.
Okay, try to solve this problem.
Option 4, sir.
Okay, I got one answer at option 4. Okay, others please try.
Sir,
Okay, yeah, tell me. Any doubt?
you have given a book website for basics and also for GATE in previous class, no, sir?
Yeah, yeah.
I have missed it. So can you give again that link, sir?
Okay, I will give. At the end of the class, remind me, I will share that link. Okay?
Okay, sir.
Okay.
Sir, in GATE calculators, can we do conversions from rectangular and polar,
No,
no, sir?
no, no, no. In that questions, they will actually give their simpler forms so that that can be easily convertible. Okay, you will not get the difficult calculation to that. Okay, so that basically to optimize the time during that questions. Okay.
Okay.
Okay, I got one more answer option 4. Anybody else who are trying? Take one more minute to solve. Okay, let me give the answer for this. So that is simple problem. Basically, the same methodology which I have told in the previous questions as well. So if you see in this question, it was asking what is the Thevenin equivalent. Thevenin equivalent means the two things, that is a VTH basically and the ZTH. Okay. So for finding the ZTH, you have to open circuit the current source because there is no impedance it is given. Okay. Open circuit the current source. So when you open circuit the current source, the circuit will look like simple like this. Okay. So this is the open circuit basically. So this is the reactance and this is the capacitance. Okay, so this is the 1 ohm and this is the 2j and this is minus j. So when you add this, because you are seeing from here, so this is zth will be equal to 1 plus 2j minus j, so it will become 1 plus j, which is equal to root 2 angle 45 degree. Okay, why 45 degree? Let's see how to convert from the polar to Cartesian or Cartesian to polar. So if you see here, what I have told, this is the imaginary plane and this is the real plane. Okay, so x value, if you see the real value, it is 1 is lying here, and here the, if you see the j is there, so j is also lying here, the positive, so this is the positive positive, so the angle will be lying in between 90 degree to 0 degree basically. Okay, so in between 0 degree to 90 degree the angle will lie. What is lying here? So it is actually tan inverse 1 by 1, that is 45 degree. Suppose I take one example, as suppose in the questions it is given that's 1 minus j. Suppose it comes like this. So how to convert from that? So in this case, if you see, this is the real and this is the imaginary. So x is positive. So x is positive coming here 1, but the imaginary it is coming negative. So negative will be something like this. It will be come here. This is minus 1. Okay. So the value will lie somewhere like this here. Okay. This is a 1 minus j. So how to take the angle in this situation? The magnitude will be same. Magnitude, what is the magnitude? Root 1 square plus 1 square, it will be root 2. What will be the angle? Angle, there will be two things, because what I have told in the previous that, so suppose you have to see the what in which section it is lying. Suppose this is a positive positive, this is negative positive, here it is negative negative, and here it is positive negative. So here what is coming? It is positive negative. So it will be 270 degree plus tan inverse y by 1. So 1 by 1, that is a mod you can take, the magnitude only. So it will be angle 270 plus 45 degree. It will be come out to be 270 degree plus 45 degree. It will come out to be 5.
Why 270 degrees, sir?
uh, you are saying something?
Why 270 degrees, sir?
Yeah, so there will be rule, no? So in this form when I was telling, if you see in this problem, so here 0 to 90 degree it is there when it is both are positive. So here in the second quadrant, if it is a wind between 90 to 180 degree, in this because it is lying after 90 degree, so this is a 90 degree, so it is lying after 90 degree. Okay, so just rule is 90 degree plus tan inverse magnitude of b divided by magnitude of a. Okay, that's why it will lie in the second quadrant basically. If you want, if it is coming negative negative, then in this situation, because it is after 180 degree, so it will, you have to take 180 tan inverse mod of b divided by mod of a. Suppose it is lying in the here, that is positive negative, so this is after 270 degree, this is 270 degree if you are taking anti-clockwise direction. So it will be 270 degree plus tan inverse mod of b divided by mod of a, or you can say simply minus of tan inverse mod of b divided by mod of a if you are here in the fourth quadrant. There are two things you can do. Now getting, have you got the thing? So basically you have to see in which quadrant basically it is lying. So here the both are positive, so there is no issue in that. So it will in between 90 to 0 to 90 degree. So that will obviously tan inverse 0 plus tan inverse mod of b divided by mod of a, that is coming 45 degree. But if it could be a 1 minus j, So it is lying in the fourth quadrant. So you have to add 270 degree, or just you have to take minus of tan inverse mod of B mod of A. That is the minus 45 degree. Any doubt?
No.
Okay, so this is simple rule. You have converting from one means format to the another format. Let's move to the suppose what we have got. We have got the root 2 angle 45 degree. Okay, so or 1 plus j basically. So this is a 1 plus j. So two option actually matching 3 and 4. Let's take the VTH value. Okay, so let me replicate it. So for finding the VTH, you don't have to do anything. You have to take the current source, whatever it is, simply like this. And this is the open circuited terminal. And here the resistance, inductance, and the capacitance is there. So this is the 1 ohm, this is the 2J, and this is a minus J. Okay. 1 ampere, what is coming? It will go directly into this circuit only because there is no voltage drop or there is no circuit. It is already open circuited here in this XY terminal. Okay. So the voltage, if you see, the voltage simply Vxy will be equal to, or V, it is simply Vth will be equal to 1 current which is flowing and the impedances 1 plus 2j minus j. What it will come out to be 1 angle 0 degree and 1 plus j. It will be equal to 1 angle 0 degree, that is root 2 angle 45 degree simply. And when you multiplying two means this two different values in this same format, you have to just multiply the magnitude, that is 1 multiplied by root 2, and add the angles, that is 0 plus 45 degree, that will be equal to root 2 angle 45 degree. So the option fourth is the correct value. Okay, any doubt in this problem?
Yes, sir.
Okay, any doubt, means you have any doubt, you're saying yes. Okay, let's move to the another problem. Try to solve this. Here there is a one dependent source. So if you know that how to solve the dependent values in the circuit Thevenin equivalent while the dependent sources are there. If you try to solve, if you don't know, just let me know. Okay, so that I can means give the glimpse how to solve this kind of problems. You can write in the chat box if you don't know how to solve this, or you can open your mic and tell me. Here there is a 3 VAB is there, and this is the A and this is the B. Okay, this is a dependent value.
We don't know.
You don't know whether should I explain whether this kind of problem? If you guys have
Yes, sir.
okay, so let me give one more minute to solve whoever is solving. After that, I will explain this. Okay. Okay. Jay Kumar is asking what is plus plus and plus minus. Okay. It means that so in this problem, so whatever I have explained, suppose this is the a plus jb format. Okay. So I was concerned about the what is the sign of the magnitudes of the real value or the imaginary value. Okay. So if you see here, this is the a plus jb. So the a, if a, I was talking about the magnitude, means the sign of the magnitude of this a, and then what is the sign of the magnitude of this. Suppose 2 plus 3 is it. Okay. So it is considered that the 2 have the positive sign, and the this j values is also values is the positive 3. Okay. So this is considered as the positive positive. Same if you see minus 2 plus 3j, so it will be considered as the negative positive, because the positive, this real part, have the sign as a negative. Suppose I have value minus 2 minus 3j, so it is minus minus. And if it is a 2 minus 3j, so it is a positive negative. So this is the meaning of this positive positive and negative positive. I hope you have got this.
Sir, in previous you wrote instead of 27 degree plus tan inverse, we can put minus tan
Yeah,
inverse.
you
How
can
it?
also take that. Depending upon what is the solution they were asking, based over, suppose they were asking the values to be in the 270 plus degrees. So in this situation, you have to take the values more than the 270. Okay. They will specify the range in which they are asking. So depending upon that values only, you have to give the answer. So suppose they were asking the angle should be in between 0 to 90 degree, but the sign doesn't matter. So in this situation, take the minus tan inverse b by a basically. Any doubt?
No, sir, how can we put minus?
So that's why, because when you take the angle, suppose this is the real axis and this is the imaginary axis basically. So this is the positive values when you are taking here. Suppose this is the, suppose I am taking a plus bj, positive, all the positive values. Okay. So the a will lie here and the b will lie here because it is positive axis. So the value will lie somewhere here. Okay. So this is the a plus jb. So what is this? So let me take another color. When you see this, so this is the b basically, and this is the, what is this? This is the a. So what is the angle? Angle is directly tan inverse b by a. Suppose if I take the a minus jb, so this is the a will be here positive and the b will come here, this is minus b. So when you take the values, suppose this is the a and this is the b, and take here, so this is the a minus jb basically here, this tip. So when you take this angle, if you see here, so theta is coming negative. Suppose this is the minus b. Let me take another pen for that. So if you see here, so this is actually minus b.
Yes, sir,
As
I got it.
okay. So that's why it is said as that this is the minus of tan inverse b by a, because the angle is coming negative side of that. Okay.
Yes, sir.
Okay. Okay, let me give the solution for this kind of problems. So this is a very important kind of problem which is generally asked in the gate also, in the means, theoretical problems also in the gate exams or the in the engineering exams. So this is a new kind of variety which I have told in the previous classes. It was just to basically to find out the Thevenin impedance just by converting the voltage source or the current source with their Thevenin means internal impedances basically. So in this type of problems, what you have to do, you have to put a voltage source. Suppose the circuit will look like something like this. Suppose this was the original circuit, that is the 5 volt, and this is the 2 kilo ohm, and this is the 2 kilo ohm, and here it is plus minus 3 VAB, and this is the values. Okay, so this is the 1 kilo ohm. Okay, so this is the 1 kilo ohm, this is the A, this is the B. Okay, so when you see here in this problems, connect a voltage source here at the terminal. So this is the V I have kept. Okay, see the method, just you have to connect one voltage source here. Okay, and assume that the current is leaving that terminal. Okay, give me 1 minute, just 1 minute. Okay, so this is the V and this is I. So what you have to find out, for finding out the ZTH, you have to just take the value Z as a V by I ratio. Okay, that will be equal to Z Thevenin basically. Okay, so this is the one method to solve this kind of problems. And when you are solving the Thevenin voltage, then you have to just open circuit and you have to just find out what the value. So let me find out first the Thevenin impedance. Okay, in this problems, Thevenin impedance will be equal to V by I ratio. Okay, okay, so just same method, short circuit the voltage sources. Suppose I have short circuited this voltage source here, so it will come out to be like this. So this is the 2 kilo ohm, and this will be equal to 2 kilo ohm. Okay, and this is the VAB, 3 times of VAB, and this is connected to the 1 kilo ohm, and this is the value equal to plus minus V, and this is the current which is coming out of network. Okay, let's find out the what is the value of Thevenin equivalent, means apply the KCL at this point. Suppose this is node A, apply the KVL at that node, KCL basically at node A. So when you apply the KCL, it will be something. Always assume that the current is leaving that terminal. See here, always assume that the current is leaving that node. So if you see the node, the current is coming into the network. So I am taking minus I, and then let's take it as a reference. Okay, so it will be equal to V by, because the voltage will appear, that is same positive negative will appear here also, this branch as well. So this is the voltage V divided by 1 kilo ohm. 1 kilo ohm I am taking V as simply, plus the current when you find out this terminal, it will be equal to V minus of 3 VAB divided by what is the impedance, because 2 kilo ohm in parallel, so it will come out to be 1 kilo ohm basically, it will be equal to 0. When you solve it, it will come out to be minus V plus V plus V plus 3 VAB is equal to 0. You have got the two equations, one equation basically. So it will value is equal to minus I plus 2V plus 3 VAB is equal to 0. Now you have to replace the VAB. How to replace the VAB? If you see here in this problem, the current which is coming here, so let me take here, so V, this is the K, and this is the, we have short circuited here, and you are finding the V by I. So we have got the one equation as this. Okay, now we need the one more equation VAB in terms of V or something, so that we can find out the values. Okay, so if you see here the V is basically the VAB only. How I am saying that, because the V is appearing across this VAB terminal only, so that's why the V which you are taking, it's a simply VAB. Okay, that is actually V is equal to VAB appearing across the terminals VAB. So that's why we have got the one more equation 2, that is the V is equal to VAB. So when you try to put the value of equation 2 into the equation 1, what you will get? You will get minus I plus 2V. VAB is already V, So I will kept it like 3V is equal to 0. So it will be 5V is equal to I, and the V by I ratio, when you find out, it will come out to be 1 by 5. It will be equal to zero point 0.2 kilo ohm. 0.2, 0.2 kilo ohm basically. So it will be 5 divided by zero point 0.2. Okay, zero point 0.2 kilo ohm. I think none of answer is actually correct. So it is coming 0.5. Any doubt in this finding out the Z Thevenin basically? Any doubt?
Yes, sir.
Which option is correct,
Third
sir?
term,
Uh, can you repeat that?
the third term, sir, minus I plus V by 1 plus again you have mentioned that V, sir. How this comes, sir?
Okay, so let me take another slide to explain this. Let me redraw the circuit. After that's also clarify you. Suppose I am taking here the same circuit, that is actually 5 volt, and there was two impedances, that is the 2 kilo ohm here, and one more here, that is the 2 kilo ohm, and there is a one dependent source that is depending upon somewhere else, that is positive negative, its value is 3 VAB, and this is the value as a 1 kilo ohm, 1 kilo ohm, and we wanted to find out what is the value of Thevenin impedance seen from this terminal, that is the A and the B, ZTH basically. So in the question it is our fellow is asking whether how we have seen this is a 2 and this is a 1 basically here. So let me solve again. Okay, so what I have told you, just have to connect a voltage source here, that is the V, and assume that the current is leaving that terminal. So Z is basically the what is the V by I ratio, that is only the value of the Z Thevenin. So in this question what I have told, just assume try to apply the KCL here. So take it as a grounded. So this is the voltage V, and this V is simply equal to VAB because it is appearing directly across the terminal A and B. So that's why it is equal to V is equal to VAB. Consider it as a equation 1. Try to apply the KVL here at the node A. At node A, when you apply the KVL, it is summation of I is equal to 0. Always assume that the current is leaving that terminal, leaving that terminal, leaving that terminal. So that's why it is considered as a positive. So in this, at this node, the current I is into the node. So that's why I'm taking it as a minus I. And this V, that voltage, will appear across here also because they are in the parallel. So that's why we have taken V divided by 1 kilo ohm. 1 kilo ohm, that is the 1. You can also take as the 1000, but that will not change. Suppose I am taking that as 1000 ohm plus this is the voltage V, and this you have to short circuit because the voltage you have to short circuit and the current you have to open circuit. So then this 2 ohm and this 2 ohm will come into the parallel, that is the 1 ohm. So the circuit will look like something like this. So it will be something 2 ohm and
Sir,
okay.
then 3VAB will also be short circuited.
No. 3AV will not be short circuited because it's dependent upon some other else values. You have to short circuit value voltage sources that is independent only. That is the one more rule for the finding out the Thevenin impedances. So you have to just short circuit the voltages which are independent. That is a 5 volt is independent. It don't depend upon any other values. So that's why you don't have to short circuit the dependent values. That's why we are using the different method to solve the values of finding out the values of ZTH. Getting my point?
Yes, sir.
Okay. So that's why V by 1000. Suppose I am finding out what is the current which is going out of this node A in this branch. So when you find out, it will be appearing as V because the voltage at terminal A is V minus minus of 3AB, minus of 3VAB divided by what is the impedance in that frame. Suppose this is the 2 kilo ohm and this is the 2 kilo ohm. So they are coming in the parallel to this, so that's why it will be equivalent will be 1 kilo ohm. Okay, so that's why I have taken here is the thousand ohm equal to 0. So when you solve it, it will come out to be minus of 1000 I plus 2V plus 3 VAB equal to 0. This is the equation 2. So equation 1 was V is equal to VAB. Put the values here, VAB V. So that will be equal to minus 1000 I plus 2V plus 3V is equal to 0. That is equal to 5V is equal to 1000 of I. When you find it out the V by I value, V by I, it will be equal to 1000 by 5, I think. So it will be 200 ohms, or you can say that 0.2 kilo ohm. Any doubt in this? This is the methodology when you have the dependent sources into the picture. Any doubt?
Clear, sir.
Okay, thank you. So let me solve the another thing which is also important, because we in this question the point 2 is missing. So I think this is the point 2 and this is the point 5. So 0.2 kilo ohm is the Thevenin equivalent. Let's find out the what is the value of VTH. Okay, let me duplicate it. So in this problem, when you try to find out what is the value of VTH, you have to redraw the circuit, because you don't need the V by I ratio in that. You just need the what is the voltage across that. Okay, so let me remove this. Okay, so suppose I wanted to find out the value of VTH. VTH in this, you don't have to any open circuit, you don't have to short circuit anything. You just have to see what is the voltage which is appearing across this AB terminal. Okay, so this is also VTH is simply equal to VAB. If you see here, this is the positive negative, that is simply the voltage which is appearing across the node A and the node B, that is the VTH is equal to VAB only. So when you see that, let's apply the KVL. Okay, so this is the 3AB. So what is happening here? So this is the 5 volt and this is the 2 kilo ohm. This is the 2 kilo ohm basically, and this is also simply you can draw it like this. This is plus minus 3 VAB, and this is also 1 kilo ohm, and this is also VAB. Okay, are you getting my point? Because they are in the because this voltage will appear across this 1 kilo ohm. So that's why the voltage which you see across the 1 kilo ohm, that is the AB, that is simply the VAB only. So that this 2 ohm, let me take the another pen. So if you see from is this 2 kilo ohm, the voltage which will appear across this, that will be 4 VAB. Getting my point? So that's why this is the 4 VAB which will appear across the 2 kilo ohm. Our interest is to find out the what is the voltages which will appear across the VAB. Okay, so let me try to apply the KCL is this point, that is simply KCL is at this point. Summation of phi is equal to 0. When you apply this, let's ground it and assume that this is the voltage V, and the one equation is that V is equal to 4 VAB. This is the first equation, because we have find it out seen that how the voltage which is appearing across the 2 kilo ohm is simply 4 VAB. Okay, let's apply the KCL at this point. This is node A, assume that. So when you see that V by 2000 ohms plus, because I have assumed that the current is leaving that node, so V minus 0 divided by 2 kilo ohm plus, take this branch, V minus 5 divided by 2000 plus V minus 3 VAB divided by 1000 is equal to 0. That is simply the KCL which we have applied at the node A. Okay, let's solve it. When you solve it, you will get V plus V minus 5 plus 2V minus 6 VAB is equal to 0. Okay, find it out value. It will come out to be 4V minus 6 VAB is equal to 5. Okay, this is second equation. Put the value from the equation 1 to the equation 2. So this is the equation 1. Put the value in the equation 2. You will get 4. V is simply equal to 4 VAB. Okay. minus 6 VAB is equal to 5. How it will come out to be? It will come out to be 16 VAB minus 6 VAB is equal to 5. It will be equal to 10 VAB is equal to 5. VAB will come out to be 0.5 volt. Okay, any doubt? Any doubt in this problem? So the methodology simply says that when you have the dependent sources into the picture, for finding the Thevenin impedance, you have to connect one voltage source and assume that the current is leaving out of that voltage source and find out the value of V by I. And in that circuit, if you have the voltage sources, short circuited. If you have the current source, just open circuited. And for finding out the Thevenin voltages, you just have to simply use the similar method what you are using for the normal method for the independent sources. Okay. So in this question, answer will come out to be second option. It is a 0.2 simply, and this is a 0.5 volt. Okay. So this is the methodology when you are having the dependent sources into the picture. Okay. Any doubt in this? If you are facing any doubt, just let me know.
Yes, sir.
Okay, let me move to the another side of problems. So try to solve this and don't take much time because we have to complete the graph theories as well. So that is also important. That will help you to solve the assignment 7. So 10-15 minutes we will try to solve the dependent sources problem. Two more problems I am having. So after that we will jump to the graph theory. Try to solve this problem. This is a conceptual question. You don't have to use any pen or paper. Just simply seeing also you can solve it. Or you wanted to solve by pen and paper, you can use that. This is a 10 volt and this is the 6 ohm. This is the R which is variable and this is a 3 ohm load. You have to find out what is the value of R at which the maximum power will be transferred to the load. Take your time to solve. Okay, I got one answer as a fourth. Okay, I request others also to solve. Okay, Sakti was asking, sir, let me explain how was 4VAB came, sir. Okay, Sakti, you wanted to explain or I explain? 6 ohm, Naresh is also giving one answer of the 6 ohm. Anybody else? Sakti, I will take your problem at the end, okay? If you are having any doubt, at the end we will take that because graph theory is an important problem and we have to clarify that also. So I got the one answer from the Sakti also 6 ohms. Okay, last 10-15 seconds I'm giving. Anybody else who are trying to solve? Okay, let me explain this problem. So when you read this problem at the first step, you try to apply the Thevenin theorems, basically that P maximum value is equal to VTH square divided by 4 RTH kind of. But that is actually not true in this type of problems. When you see that Because the problems was like this. This was the VTH and this was the RZTH basically, and the some load was connected. In that situations, that power maximum will be equal to VTH square divided by 4 times of Z load basically. And different methods are to find out the what is the value of Z load. But here the load is not variable. The what is the variable? Variable is the inside component. Inside component is the R value. So it is saying you have to maximize the maximum of load. Okay, but it is not dependent upon, the function is not dependent upon the R directly, because the load is actually fixed at a 3 ohm. Okay, so how to find out this problem, the maximum values? In this problem, just write the equation of the power load, because what you have to maximize, you have to maximize the P max load only. So in this problem you have to just write the value of P load. What is the value of P load? P load will be equal to simply I square 3. Okay, let's take the values of I, let's put the value of I in terms of R. Let's, how to do that? It will be equal to 10 divided by R. Suppose I am taking this as the Z dash. Okay, Z dash I am taking. So let me take another plane. So let's assume that this is the Z dash. So it will be equal to I is equal to Z dash plus 3 I square, that is the V basically, square multiplied by 3. Okay, so what is the value of Z dash? Z dash is equal to simply 6R divided by 6 by R. Okay, or you can simply say that because 1 by Z dash is equal to 1 by 6 plus 1 upon R. Okay, so it means that when you wanted to maximize this Z dash, because if you wanted to maximize this P load, you have to minimize the denominator term. Okay, so when you wanted to minimize this below term in this, suppose you wanted to minimize this Z dash. Okay, when you wanted to minimize this Z dash, and 1 by Z dash will be get maximized. So that's why you have to maximize the value of 1 by R. That is the complementary, because when you increase, when you get the maximum value of 1 by Z dash, only when the 1 by R will be the maximum value. Okay, that because it is in the addition. Are you getting my point? You wanted to maximize the P load. If you wanted to maximize the P load, you have to minimize the denominator, that is Z dash. If you wanted to minimize that Z dash, the 1 by Z will be maximized. Z dash will be minimum, then 1 by Z dash will be maximum. And when the 1 by Z will be the maximum, only when the 1 by R will be maximum, because it is in the addition. When you will get the value of 1 by R at the maximum value, when you kept the R at 0. Are you getting my point? Because that at that moment 1 by R will be tends to infinity. Okay, are you getting any doubt in this? So that's why the answer will come out to be 0. Simply when you short circuit this R also, that at that moment the maximum power will transfer to the 3 ohm, because there will be no power loss in between the circuit if you have the any control in between. Any doubt in this? If you wanted to explain again, I will explain it.
Infinity is greater than 0, Nasa.
Yeah, but the question, if you see here in the question, the R is actually variable. The internal R which is there into the circuit, it is actually variable. So if you wanted to maximize the what is the load power, in that situation the R you can keep it as a 0, because there is no range is given of the R. You can use the 0 value also, means short circuit also simply, or you can open circuit also at taking that R is equal to infinity or R is equal to 0. Getting my point? There is a no range is specified so that you can take any values, 0 also, infinity also, 3 ohm, 6 ohm, 9 ohm, 12 ohm, any value. But at which value you are getting the maximum power across the load? That is the important point. Are you getting my point? Let me explain it through the some other sense, so that will make you the easier to understand. So let me another slide. Suppose there is a one circuit here. There is a one circuit, and this is the R, which is variable, and here it is given already 6 ohm. Okay, and here 3 ohms is already given, and there is a 1 5 volt. Suppose I am taking here. So let me take at which situation the maximum power will be transferred. If you short circuit it, the R value, the when you short circuit this simply short circuit, this 6 ohm will be there here, and this is the 3 ohm here, and this is the 5 volt. When you short circuit this, the current will flow through this path only. Let me take another pen. So the current when you leave from here, it will simply flow from this circuit. It will never will go into the 6 ohm. Okay, so there will be no power loss. Current which is flowing here, it will not get divided because it is sorted part, minimum resistance part, that is R is equal to 0. So that's why it will take the minimum resistance path, then it will move to the 3 ohm. That's why the I will be maximum, it will come out to be. There will be no voltage drop inside of the circuit. Another sense, if you see I open circuit that, suppose I am open circuiting that, suppose I open circuit this 6 ohm, and there it is 3 ohm. So in this problem, if you see, the current will flow from here, it will simply flow from the 6 ohms also. So the power loss will be I square 6 ohm here, and the power which is coming here, that is the I square 3. So the sum power will be flow come inside of that also. So the maximum power which is to be transferred to the 3 ohm, that will not come into the picture. Okay, are you getting my point?
Yes, sir.
Try to solve it at home, you will get the clarity why it is coming. I will share the slide, try to solve, you will get the clarity. Try to solve this problem. In this problem we use the same concept. Connect a voltage source at the terminal. It is asking, assume the current is leaving, simply like this, node 1, node 2 is given, assume there is a one voltage source in between V, and current is leaving that terminal. Okay, take the value of V by I ratio, you will get the answer of ZTH.
We can simply reduce the circuit impedance resistances. 9K, 1K, and 100 ohm.
But there is a one catch. One catch is there because the current is dependent. You can use that ki 9 ohm plus 1 ohm is in series. Okay, that is simplify the analysis. That is true. and you can also take the IB that is following in the same circuit. You can reduce that, but you should not reduce that 10 ohm, then kilo ohm with the 100 ohm. Okay, in that situation the IB means the characteristic of IB will be lost. Okay, are you getting my point? Because in that situation the IB was flowing in this branch, but when you are taking the 10 kilo ohm in parallel with 100 ohm, the IB, then the IB will not be the same. Then the same current, the current will be summation of IB and also the current which is flowing from here, this node. Then you can assume that ki out of that network the current will be summation of both IB plus the current which is flowing through the 100 ohm. Then in this situation the characteristic of the IB will be lost. Okay, simply use the KVL by making the voltage and current like this. Okay, make the two equations, you will get the answer. Don't reduce the circuit.
Yes.
Okay, anyone who have got the answer, take your time to solve. There is no need to rush. Simply use the V by I ratio, you will get the answer. If you're not getting, means if you want me to solve, then that is also fine. I will solve that. Take last 1 minute. Okay, let me explain this problem. Okay, you will get the clarity. Okay, see here, uh, in this problem it was asking what is the impedance when you look from the 1 2 terminal, from the node 1 and 2. Okay, so what I have told you, just have to connect a voltage source across this and you have to solve the value of the V by I. Suppose let me take here one voltage source V and assume that the current I which is leaving that voltage source. Okay, so what will be the value of ZTH? ZTH will be simply equal to V by I ratio. Okay, so let's apply the KVL. Suppose let me take it as a grounded here, and this is the node A, so this is simply a node A. Okay, that is, there is no voltage drop, so assume that this is a whole node A. So let's apply KCL here at node A. The current summation of I is equal to 0, assuming that the current is leaving that node. So when you see that the current which is coming I, current I, capital I, it is coming into the node, so that's why it is minus I. And when you see the 99 IB, it is also coming into the node, so that's why it is minus 99 IB. Take the, because the voltage which is V, that same voltage will appear across the 100 ohm and also the voltage across this as well. Okay, so what it will be? It will be equal to V divided by 100 plus V divided by 9k plus 1k, that is the 10k, basically the 10,000 is equal to 0. Now we have got one equation in terms of Vi and 99 IB. Now the second goal is to remove this value of I by finding out the second equation. Okay, how to find out the second equation? When you see that this 9 and 1 ohm, that you can write simply like this, that is the 1 ohm, 1 kilo ohm, that is the 9 kilo ohm. Okay, in that parallel the 100 ohm was there. Okay, and the current which is flowing into that, that is the IB, and here that is node A, and here the voltage source is there, plus minus V. Okay, so when you see that this same voltage V will appear across this IB as well. Okay, get in this branch basically. Okay, because they are in the parallel of this 100 ohm, and this 1 kilo ohm and 9 kilo ohm are in the parallel. So the V will come out to be minus of IB multiplied by 9 plus 1, that is the 10 kilo ohm, that is 10,000 ohm. Getting my point? Because they are in the parallel. Okay, so that's why we are actually avoiding avoiding the reduction of the branches basically, by applying the resistances in the parallel and all. Okay, getting my point? So putting the values into the, so give me 10 seconds. अरे यार चिल्लाओ मत. So what I was telling, we have got the two equations basically, and we have to solve this two equation to get the values. Okay, so this is the equation 2. Let me put the equation 2 into the equation 1. So this is the equation 2 and this is the equation 1. Let me put the equation 2 into the equation 1. You will get minus I minus of 99 I. What is the IB? IB will become minus V by 10,000 basically. Getting my point? Minus V by 10,000 plus this V by 100 and this 10,000. When you add these two, it will come out to be multiplying this by 100.
So
Yeah.
how V is equal to minus IB 10,000 came, sir.
When you see these two branches, let me take another color. When you see these two branches, this branch 1 and this branch 1, they are in the parallel. And if the two networks, the two branches are in parallel, so that's the voltage across that, it will be the same. So that's why I have kept the 1 kilo ohm here, 9 kilo ohm here. So this is the one branch. When you see that, this is the one branch, and this is the second branch, that is the 100 ohm. Okay, so the voltage, this is a node A, so that's why the voltage is coming across the both branches. So that's why it is the parallel networks. Voltage source 100 ohm and this 9 kilo ohm and 1 kilo ohm, they are in the parallel. So that's why the voltage, that the V will appear across the this branch. Okay, so the current which was flowing was IB, so the voltage across that the V, so the voltage means V is equal to IR simply. So minus I, because the voltage is current is coming into that voltage source, means opposite direction of that. So that's why it is V is equal to minus IB times of 10,000.
10,000 is parallel with 100 ohms. R1 R2 by R1 plus R2 within.
That's true. That's true. Let me again clarify that. Let me take another slide for that. Suppose I have one voltage source here. This is a voltage source V, and there was one resistor connected here R, and one resistor connected here R1 and R2, and some other networks are there. So if you see here, the same voltage will appear across this, and the same voltage will appear across this. So the voltage here will be V, and here also V. So what in the question was there, the current was going like this was the I. So it, but V will be equal to I times of R, but the current is going into that network. Okay, so that's why I have taken minus I. What is the R here? Suppose this is R dash, so a minus I times of R1 plus R2 simply. Okay, so the current there was, it is minus IB, so R1 was 9 kilo ohm plus 1 kilo ohm, so that's why I have taken directly the minus IB times of 10,000 ohm. Are you getting my point?
Yes, sir.
Okay, so if you see here, try to solve this, minus I here, plus 99V, and this 101, you will get 200 times of V divided by 10,000. Okay, try to find out the what is the value of V by I ratio. When you solve it, you will get 10,000 divided by 200. Okay, 0 0 cancel out, it will come out to be 50 ohms basically. So the correct answer will come out to be option first. Any doubt in this? Any doubt? If you wanted me to clarify anything, just let me know. Okay, if you got the clarity, try to solve the last problem of this kind of sets. Okay, this is the one problem. You just have to find out what is the value of VTH seeing from the AB terminal. This is the AB terminal. You just have to find out what is the value of VTH. Try to solve it, and this is the last problem of this equivalent circuits kind of network theorems. Last 2 minutes to solve this problem. Last 1 minute.
minus 19 volts.
Minus 19 volt. Okay, I got one answer. Anybody else? Just simply use the KCL at this node. Okay, and try to find out the two equations which can solve the value of VTH. Okay, minus 0.25. I got the second answers as well. Okay, let me solve. See here. So I'm solving this problem and try to see how actually this kind of problems can be solved. Okay. Here what is given that you I got one more answer as a 20 volt. Okay. Let me solve this. So when you say that it is asking what is the value of VTH basically, here it is not asking ZTH. Thevenin impedance it is not asking, then you don't have to use the V by I ratio. Okay, simply. Whether it is dependent or independent. Okay. So now if you see from the AB terminal, it is actually the VTH. Okay. Let's ground it and try to apply the KCL at this node. When you apply this current I is going into this 1 ohm. So summation of I is equal to 0. If it is going out of that node, it means it is positive of I. What about this branch? That is simply plus V minus 2 by 1 ohm plus, if you see this branch, for about this branch, that is simply the V plus 20I divided by 2 ohm is equal to 0. Let's try to give the one equation in the simpler form. That is 2I plus 2V minus 4 plus V plus 20I is equal to 0. Or you can say that 3V plus 22I minus 4 is equal to 0. That is equation 1. Okay. That is simply we have done, that is plus I and V minus 2 by 1 plus V plus 20I by 2. Simply solving 2I plus 2V minus 4 plus V plus 20I, that is 3V plus 22I minus 4 is equal to 0. Now for finding out the VTH, if you see here VTH, you need the voltage across the 2 ohm. Okay. So let's find it out the value of if you see that this 1 ohm, that is 1 ohm, where the current I is coming, it is simply in parallel with this circuit, minus plus 20I plus 2 ohm. If you see that this is the VTH basically. So how to let's try to find out one again. This second equation will look like something like that. The voltage which appear across this branch will be same voltage which will appear across the other node, this branch. Okay, because they are in the parallel. So what is the voltage across this branch? That is I multiplies by 1 ohm, which will be simply equal to minus 20I plus VTH. Getting my point? So this is the second equation. So simply the VTH will be equal to 21 times of I. That is the second equation. We got the two equation, but here the unknowns are three. So you need the one more equation. Okay. So how to solve this? So when you see that, how to solve this? So I here, the V here, simply here, and the VTH. Okay. Mm, 21I and then V. Okay. Now one more equation is simply like this. V is equal to, capital V is equal to I basically. So this is the third equation. Why? Because the voltage which is appearing across this node, that is simply the V only. Okay. Which is equal to I times of R. Simply this is the third equation. So we have got the three equations, and you can find out the what is the value of VTH. Let's put the equations, all the equation into the first equation. When you see that 3V, 3 times of V, 3 times of V means V is equal to I. Okay, so let's put the value 3V. V is equal to 3 times of I plus 22I is equal to 4. What will be the I value will come out to be? I will be equal to 4 divided by 25. Okay, let's put this value in this equation. So VTH will be equal to 21 times of I, that is a 4 by 25. Okay, so it will come out to be 4 and 8 divided by 25. When you solve it, you will get something 84, 2 times of 50, 375. It will come out to be now 90.03, so nearly 3.3 something volt. Getting my point? So just simply you have to use the KVL and the KCL here in the while solving the VTH values in this kind of problems. Any doubt in this?
Yeah.
If I have done any mistake, try to solve again at the home to get the correct value, and I will solve the correct value if I have done any mistake. After that, I will uh, keep the slides on the that folder. Okay. Any doubt? Methodology have you got? That is more important.
Sir, I have done in another ways.
Okay, you have done, if you have done in another way, try to solve it. Check the whether the methodology is fine or not. Okay.
Voltage through 1 ohm is 1 volt, no, sir?
Yes, that is true because the voltage through 1 ohm will be V is equal to I times of 1 ohm, that is equal to simply I.
Then 1 volt is equal to 20I plus
Not 1 volt, that is a I.
2
I, that is not 1. This is a I, not 1 ampere. So it is dependent. That voltage is actually
by
dependent upon it.
voltage division rule. I have written uh, across 1 ohm is 1 volt, sir.
Okay.
Then 1 volt is equal
No,
to
no, 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 no.
20I plus.
That is wrong. That is wrong method. When you cannot directly simply divide the voltages across this. Are you getting my point? This is division only possible when the voltages and the impedances are like this. If you have any other branches also into the system, you cannot simply divide the voltages. You have to see what is there into the other networks as well. Okay, because the current which is flowing here, that is not the same current which flow here, that is the I dash, because the I current is going somewhere else as well. Are you getting my point? You cannot simply divide the 2 volt into this. That is simply possible when the two resistances are in the series. They are not in the series. 1 ohm is in series with the 2 volt, but not the 1 ohm, because the other branches are also there. Getting my point? So this is a kind of fundamental mistakes. So this will be get clarified when you solve lot of problems on the network theories. Getting my point?
Yes, sir.
Okay, try to solve it again. Then after that we will see whether for GATE exam which book I refer for the network analysis. So that is Sadiku only. I will give the link of the to download that book. Okay, or simply you can type in the Google as well that Alexander and Sadiku. I'm giving the name, you can take the screenshot, Alexander and Sadiku, for the network analysis. Take the screenshot, search on the Google, you will directly get one link which is in the drive itself. You can download it from there. There is a lot of problems are there. And for the fundamentals, you should study this book. That is more important. I will recommend that. Okay. Okay, let's move to the graph theory. So we don't have a lot of time. So I have kept few of the definitions. Okay. You just read it out. You will get the understanding of what is tree, what is twig, what is node. Node, I have explained that this is the intersecting points between the two branches. That is the this nodes. Nodes, why I am telling, because there are three greater than two elements are connected. Okay, so that's why it is called as a node. Okay, node and junction. Try to see the difference between the node and in between node, that is this is the branch, or you can say that this is a link. Okay, so if you see this circuit, this network can be simply converted into this by short circuiting the all the elements. If you see that this is short circuited basically. So the nodes where the two more greater than two elements are connected, that is actually the nodes. So this is the node 1, node 2, node 3, node 4. And these are the connecting branches between the two nodes. They are called as link or the edges. So when you see the assignment 7, there the few questions are related to incidence matrix, cut set matrix, tie set matrix. Okay. Our goal of this lecture is to find out how to find out the incidence matrix, cut set matrix and tie set matrix. That is our main goal. Okay. So let's move to the finding out the what is the incidence matrix. Okay. Have you got the how to convert from one network to graph? Okay, I have kept the lot of slides. Just read it once. You will get the clarity of what is tree, what is branch, what is sub branch. That definitions I have kept. Okay, I am moving to how to solve the how to make the matrix of incidence matrix. Okay, suppose there I have one graph. This is the graph. There is no elements. All elements are short circuited and there are different nodes. These are the nodes 1, 2, 3, 4. These are the nodes. And this A, B, C, D, E, F are the branches. And there are two types of branches or links. They are directed or non-directed. Directed means when the arrows are given, the direction of the current is given. Suppose here also it is given, here also it is given, here also the current directions are given. Okay, so these are the directed graphs. Okay, then how to find out the value of incidence matrix? Okay, suppose forget everything, just see the node A, node 1 only. Okay, forget everything, see only node 1. What I am telling, you just have to see the node 1, forget everything. If you see the node 1, okay, there are three currents which is going out of that node. Suppose this is the one current which is going, this is the second current which is going, this is the third current which is going out of that network. Okay, and this node is connected to how much other nodes also, that is connected to the node 2 through this branch A. This is also connected to the node 3 with F branch. It is also connected to node 4 with C branch. Okay, so this is the incidence matrix A simply, whose columns are actually nodes and whose rows are branches. Okay, it means that suppose I am taking the node 1 and taking the node 1 where it is going. Suppose it is going to the 2, node 2, and it is out of that node, it is considered as a positive. So Aij is positive 1, if the jth branch is incidence to or oriented away from the ith node. Getting my point? So always assume that why I have told that always assume that the current is going out of that network. So that's why, because if you see that if it is going, if the jth branch is incidence to the oriented away from the ith node, that's why it is called as positive one. Okay. If you see here the node 1 is there. See the other branches A, B, C, D, E, F. Make when you are making the A matrix, always make like this: node 1, node 2, node 3, node 4. Write all the nodes, whatever there, and write the branches in the rows D, E, F, G, something, whatever is there. Okay. Then see that from that node in that branch it is going out or going in. Let's take that. If you see here, the positive 1 is given. Why it is given? If you see the A branch is here. A branch is here. It is going out of that. So A branch is, it is going out of node 1 in the A branch. So that's why it is positive 1. Whatever, why it is 0 in the B? Because it is nowhere is it connected to the B branch. Okay. So node 1 is not connected with the B branch. That's why it is 0. Why it is positive one here at the C? If you see the C, this is the C, it is going out of that, so that's why it is kept positive. What about why it is D is 0, E is 0? Because it is not connected with D and E branch. Are you getting my point? See, in this question type of questions, always see whether it is connected or not. If it is not connected, consider it as 0. If it's going out of that node, consider it is positive of that branch. Getting? Suppose let's remove for the node 1 and see let's focus on the node 2. Node 2. Suppose I am focusing on the node 2. If you see the node 2, current is coming into the node 2 from the A branch. That's why it is kept as negative. If you see that this is -1 in the B also, because the B there the current was coming like this. Here it is not given, but it is like this. When you see the D also, it is going out of that. So here also it is actually positive. It will come. If it is coming into the network, it is negative. It is going out of the network, it is positive. Any doubt in this? Forming this incidence matrix? Any doubt? What things you have to see? How many nodes are there? How many branches are there? Write the nodes in the column rows, that is the first, second, third, fourth, and then write the branches A, B, C, D, E, F, and then see the orientation basically. If it is going out of the network node 1 in the A branch, consider it as positive 1. If it is not connected, consider it as 0. If it is going into the network, it is -1. This is the methodology to find out the value of incidence matrix. There is a one question also there. You have to find out what is the value of incidence matrix. For non-directive branches, sir, so in that situation you can assume that any direction of the current, okay, if it is not given, okay. Suppose there is a one branch which is connected between A, B, there is no current is given, so assume that any assumption you can take like this also, okay. Make a one matrix assuming that, okay. But in the most of the questions, uh, in most of the question it will give, if it is asking incidence matrix it will give definitely, okay. There is no issue in that. So let's take the what is the value of reduced incidence matrix. There is a one another matrix is reduced incidence matrix. Incidence matrix, that is the sub matrix of this. Suppose, let me take another slide, remove this. Suppose there is a one here, this is what I have told, this is the matrix A which is equal to 1 2 3 4, they are the nodes, and here the A B C D E F will be there, they are the branches basically, okay. So what suppose I wanted to reduce one branch. So in that situation, suppose I removed this. Okay, so this what is left here, that is the only 2, 3, 4 branches, and B, C, D, E, F is actually a sub-incidence matrix. Means it is a part of the incidence matrix, but at some of the nodes will be missing and some of the branches will be missing. That only you will remove in the column wise or the row wise. Suppose this row only we have missed and this column we have missed. Okay, so that is the subset of this matrix. Sub incidence matrix is a subset of incidence matrix. Okay, some theory I have kept, you should go through it, you will get the clarity. Okay, so basic things are there how to find the incidence matrix basically. Let's make this one more thing is there, that is the tie-set matrix. Tie-set matrix, if you read it this, for a given tree of a graph, tree is basically there is a no closed loop will be there. Suppose this is the one network is there, one graph is there. So the tree will be something look like this. Suppose this is node A, node B, node C, node D. So it will look like something this. There will be no closed loop and it will be connected to all the nodes. And other form will be something like this. So this will be something like this. So this is also one tree. Okay. I have kept the definition. Read it out. You will get the clarity. Okay. Definition wise. So this is a tree. So it means that addition to each link between the any two nodes form a loop called as the fundamental loop. So mota let me explain directly to the what how to solve that. Suppose this is the one graph here. If you see that here the A node is there and this is the B node and this is the C node and this is the D node. Okay, and some current directions are given. Suppose this is given as I1 and this current direction is given as I2 and this current direction is given as I3. Okay, now I have to find out the what is the tie-set matrix. Okay, so in the tie-set matrix you have to write the nodes here, loops here. If you see here, the rows are simply I1, I2, I3. They are the loop currents. Getting my point? So these are the loop current, and on the x-axis, if you see there, here the in the column wise, it is branches. Getting? So branches are 1, 2, 3, 4, 5, 6. So there, if you see here 1, this is 2, this is 3, this is 4, this is 5, this is 6. So these are the branches. Okay. So let's take the direction of I1. So I1 was moving like this. So if you see that this loop is like this. So when you move in the direction of current, so it is crossing the first branch, fifth branch and sixth branch. Getting? So if you see in the row wise also, this is a +1, +5, 6 is negative because the current was there. It was moving something like this. Let me remove this again. So if you see here, the current is moving like this. Okay. The sixth direction was different when it is moving. So it is simply like this. Suppose if you see it is like this, the current was moving like this and the east direction is like this. So loop was something like this. So it is different in direction with the sixth branch. So that's why it is kept negative. If you see the I2 current, I2 is actually in the second branch, fourth branch and fifth branch. See the direction, only the values, non-zero values will be in the 2, 4, 5. And where it is positive, 2, because it is in the same direction, that's why it is positive. In the fourth, it is also positive in the same direction, but in the fifth, it is in opposite direction. That's why it is negative. Getting? So it is simply to represent in the loop and the branches, how the loops are actually it is there. Okay. So this is the methodology to find out the value of the tie-set matrix. You have to see what is the loop currents. Here the direction will be given and also the incidence of the currents is also given at the different nodes. Okay, you will get to find out what is the value of tie-set matrix. So this is a simple manner to find out the incidence matrix and the tie-set matrix. Now the thing is how to find out the cut-set matrix. So if you see here, so this is the one graph here, and this is the oriented graph. Oriented graph means where the current directions are given. Okay, here also current directions are given. So at each node you can find out the cut set matrix. What you have to do, you have to just make a semicircle out of that one arc, which is kind of say circling the node A. So if you see the cut set means how it is actually cutting the two branches. So if you see here, the two and one branches it is cutting. So let me take the one more thing here. Suppose in this, if you see here, suppose this is the node A, this is node B, node C, node D. Okay. So if you are cutting here, so it is cutting basically the node 2, branch 2 and branch 1. When you are cutting here the node B, means circling here, so it is cutting 2, 3 and 4. When you are cutting the C node, it is actually simply the fifth and the fourth. And when you are cutting this here, making a semicircle, it is actually the fifth, third and first. Okay. So here also it is saying that if you are making the cut set here, what branches it is cutting, 1 and 2. Cut set 2 means C2. C2 basically if you are taking the 2, 3, 4, this is the B at node 2, it is C2. Is it 2, 3, 4? When you are making cut set 3, that's it node C, it is 4 and 5. If you see the cut set 4, here the 1, 3, 5. Okay. Cut set 5 and cut set C5 basically the you can cut the more than two nodes as well. Suppose you are cutting here the two nodes here like this or here. Theoretical part you can read it out, you will get the clarity, but it is simply that how you are cutting the nodes basically. Now to find how to find out the cut set matrix, there is a one thing that suppose there is a one node A, the two branches is going here. If you are cutting here like this and the orientation was something like this, okay, there is a one assumption you have to do. Suppose you are assuming that the cut set is like this is the assumption. Okay, in this situation the 1 2 branches, when you are finding out, you have to take the minus in the branches, that is a -1 here, -1. Let me take the matrix itself. Suppose here you have to write C1, C2, C3, C4, C5, C6. They are the cut sets, and you have to see the branches. Suppose in this problem at node A, you are making the C1 cut set, and the 1 and 2 branches are actually connected. In this situation, only the 1 and 2 value will be the positive and negative, or the value will be non-zero. Other values will be 0. Same with the C2, where if the current is cutting particular branches, then it is a non-zero, otherwise it is 0. Okay. Then in that situation you have to see how the orientation is there. Suppose this is node A and the two branches are there and the current was going out of that, and the orientation you have taken like this. So in this situation C1 you have to write this 1 2 3 4 5 6 like this, means some of the branches. At 1 it is going out, but you have assumed opposite of that, that's why it is -1. At 2, -1, it is not connected other, so that's why it is 0. This is the simpler way to find it out the value of cut set matrix. Okay, getting my point? I have kept the theory, just read it out. There are the simple methods to find out. When you're finding out the incidence matrix, take the orientation of that at the particular node, how the current is leaving, or suppose this is the incidence matrix. Node you have to draw in the x-axis, means row wise, branches in the column wise. See the orientation of the currents, how it is moving. Okay. Similarly, same with the cut set matrix, tie set matrix, tri-set matrix. You have to see the loops. If you see the loops, how it is moving into the branches. Okay, you can draw the cut set, tri-set matrix. And for the cut set matrix, see at each node the cut set will be formed, and if it is cutting the branches you have to take the non-zero values, if it is not cutting you have to take the zero values. Okay, I have kept everything in the slides. You just go through it once, you will get the clarity. What is the tie set matrix, what is the cut set matrix, and what is the trees, what is the branches, what is the graphs. Okay, every definition I have kept. Any doubt in this? You have to read the slide basically.
So what's the use of all these matrices?
This is the a simpler way when you are, suppose you have the 36 branches, 50 branches, 100 branches. You cannot simply do it by manually solving. You cannot do it. You cannot make a KCL out of that. You cannot make the KVL out of that, of the 100 branches, 200 branches. This is done for the computation purpose. The computers usually what they do, they know the only the cut set or incidence matrix. They simply make the equation out of that. Getting my point? So this is to be simplify the methodology for finding out the voltage and current. Suppose I take the one example. Suppose I am taking this example. This is the matrix which is formed between the I1, I2, I3 current loops. What computer will do for the computation purpose, it simply see the whether it is positive, whether it is negative. Okay, so -1, 1, 0, and simply they will make the equation. Suppose how to make the equation, this simply will make the V1 plus V5 minus V6 is equal to 0. Okay, so this is simpler way to find it out the KVL and KCL equations for the loops and branches. Suppose here I have kept here like this. Suppose I wanted to find out the only the branch currents and simply the loop currents. So this B matrix will help me to finding out the directly the IB matrix or IL matrix of the 100 of the branches, 200 branches, 300 branches kind of. Getting my point? So this is the simpler method
We
for
can
the
use for
computation. Yeah.
the less branches and less nodes also,
Yeah,
is it?
yeah. So basically, if it is a zero, most of the places it is zero is a kind of a sparse matrix, and the space which is consumed inside for the storing of the values or computation purpose is easier. Okay, that's why it is kept means used for the calculations as well. Okay, just read the slides, you will get the clarity. Okay, and try to solve the assignment 7 problem. Okay.
Yes, sir.
Okay, so that's all for the 2 days, and I hope you have got the few of the things which I wanted to explain. And if you have any doubt, we will go through that in the next tutorial session, tutorial 8 basically. Okay, thank you so much.